Snow, hail, and Graupel. We're going to talk about their formation, we're going to talk about their differences, and we're going to talk about the hazards that they produce, predominantly focusing on hail, because this is the sort of a hazard that is most frequent to a lot of people, and also is least understood about some of the damages that it can do and how you need to be safe, because alongside with hail you often get lightning, which can be very dangerous. So we're going to start off with the formation of snow, which is rather fantastic and rather strange to think about in the middle of the summer, like why we're talking about snow. So let's actually think about it. A snowflake begins to form when you get this super cooled water droplet in the sky. And what it does, it goes around a little nucleus of either pollen or dust, some tiny, tiny particle that's very difficult to see. Well, the water droplet goes around that, but actually in the sky, it slowly freezes because it's very, very cold. And you start the formation of an ice crystal. Now, when the water freezes, it freezes into a beautiful hexagonal shape, because this is how the molecules inside the water arrange itself. Now, what happens is we've got 1, 2, 3, 4, 5, 6 sides of our hexagon. And on each corners of the hexagon, as that snowflake keeps on falling and it comes into contact with more water vapor, it grows these little new branches, 1, 2, 3, 4, 5, 6. You'll notice something about them as well. They're almost identical, these little branches, as they come down. And it starts giving us this beautiful snowflake, which is rather fat. Now, because the atmospheric conditions are the same on all sides of the snowflake, this is why we get this wonderful symmetrical snowflake shape. In other words, each one of those branches that come out from that initial hexagon are identical. But because as it floats down to the ground, it comes into contact with different atmospheric conditions, it gives us a completely different snowflake. And this is why we have the phrase that no two snowflakes are real. But don't take my word for it. Have a look at this little video clip. Now, if for any reason this doesn't pick up the audio properly, just click on the PowerPoint and then click on the YouTube link, and it will show you that in the YouTube link. So that should be fine. So let's just have a look. And here we go.
A snowflake begins to form when a supercooled water droplet in the sky freezes onto a dust particle or pollen, forming a tiny ice crystal. However, when water freezes, its molecules arrange themselves in a hexagonal pattern, thus giving the crystal a hexagonal shape. Now, as the ice crystal keeps falling, it comes in contact with more water. As a result, the water starts freezing on the 6 corners of the ice crystal, causing branches to grow on the corners and thus giving us a beautiful snowflake. Also, as the atmospheric conditions are the same on all sides of the snowflake, the branches grow identically, thus making the snowflake symmetrical. But since every snowflake follows a different pattern to the ground, it encounters different atmospheric conditions. Hence, it is said that no two snowflakes are the same. They all tend to be unique.
So that tells us why the snowflakes are unique and how they form, which is really cool. But there's another thing as well. Everybody knows that snow is white, at least that snow that's not kind of been stamped on or things like that, or had other colors introduced to it. But there's a scientific reason for this, which some of you may know and some of you may not. But let's actually have a look at what this happens then. So as light comes through and it hits that crystal there, the reflected light that comes back from it reflects all of the colors, like I've got here in my all of the colors little rainbow, which together look white. Now, if you don't believe me, have a look at this diagram at the bottom right here. And you can actually see we've got red, green and blue. Now this red, green and blue, right in the centers they're red, green and blue, but they're different shades of red, green and blue. And TV sets used to be made up of these 3 colors. And when you see something that says RGB color values, that's what that means. It means the red, the green and the blue. If you shone all these lights together to make a Venn diagram of different colored lights, as you can see, when you mix all these colors together, you actually start to get in the middle white. And this is where you've got all of the visible colors of light that add up to the white. Let's take some other examples though. If you have a red sweater, or what I would call a red jumper because I'm English, the red sweater absorbs all of the colors except for red and then reflects the red back out for people to see. And exactly the same thing here with our yellow tennis balls as well. All of the colours are absorbed except yellow, and yellow is reflected back. And this is how visible light works and how we perceive colour. So this is quite a cool fact about snow. Okay, so this may seem a little bit fast. So if we're going too fast, you can pause this video, you can go back, or you can pause and go back through following through the PowerPoint as well. The point of this is to do this at your own speed in your own time. If you're comfortable going fast, that's fine. If you're comfortable going slow, that's also fine. So I just wanted to reassure you that when we start. So we're now going to look at hail formation, and this is the main thing that we're going to do today with the main activities that we've got today, all based around hail. So a little bit later on, there is a hail mystery, a creepy mystery, which would be good fun to get into. But first of all, I wanted us to actually look at how hail forms. And we're going to do this in a couple of ways. I'm going to take you through some of the PowerPoint slides. We're going to go through the diagrams. And what I'm going to then do is, if you're a younger child, there is a fill-in sheet for you to fill in based on some of the things that we're going to talk about here. So now would be a really good time to make sure that you've got that sheet in front of you that talks about hail formation. If you're an older child, what I'm thinking about that you might be able to do is actually draw this diagram for yourself. Drawing the diagram is really useful because it helps you to remember what you've done and understand it. But it's also a key geographical skill. So if any of you are interested in the weather and meteorology, or interested in geography or geology or any of those sort of the physical science side of things, we tend to draw diagrams a lot. And we do something else to them as well. We put labels on them, and we call these labels annotations. And that helps us understand what's going on in the diagram. So I'm going to talk you through this, and then I'm going to show the diagram as well being caused in a graphic design, created in a graphic design package, and hopefully that will help you understand things. Well, let's first things first then. So what we have is a great big cumulonimbus cloud. That's what this diagram is showing you here. A cumulonimbus means a rain-bearing cloud. If you hear the word nimbus, that means, I think it's from the Latin, and that means rain-bearing. And what happens is hail forms in this, it has lots of moisture and wind and different atmospheric conditions. But the first thing you need to think about here is this. When you looked at the water cycle at school, you probably would have learned that the sun comes out and it kind of evaporates the moisture off the ground and off of the leaves and off of surfaces, and that rises in the air. When it rises in the air, when it gets to a cold point, it condenses. And similarly to us talking about our snow earlier on, it forms usually around a dust or pollen nuclei. So the same principles as we were talking about in snow, at least at the start, they tend to start off like this. But these raindrops might be falling from this thunderstorm, and there's heat from the ground as well. And this heat from the ground pulls these things back up into the cloud. Now, as they go up into this updraft in the cloud, they get really cooled really quickly. They get super cooled, and they start to become little small ice crystals. Now, what happens is that they're constantly being buffeted and moved around by wind. Remember on this slide, it says it's a dance between moisture and wind. And what happens is, as we have updrafts pulling them up, it pulls them up, they start to freeze, but then they start to tumble down towards Earth again because of gravity, and they start to get heavy. And then they start to melt maybe a little bit, but then they get pulled up by another updraft, and then a new layer gets put on them. So they get larger and larger and larger. And this is pretty much what happens in here, pushing them till they get very, very high into the ground. This is repeated several more times until they become so heavy that they start to fall down to Earth as hail. As this goes over and over and over again, you get slightly larger and larger hailstorms. When, by the way, it finally does get pushed back down, you get this cool downdraft with it. And you may notice it if you're close to a thunderstorm as well, that it gets a little bit colder at just before you feel the thunderstorm or even the rain or hail starts. It sometimes gets colder. So that's something that's useful to remember as well. Hopefully these diagrams and the explanation that's given on the PowerPoint there give you an idea. Again, if it's going a bit too fast, if you're not too sure, if you don't understand the diagrams, it's okay to go on the internet and actually look for these things as well on YouTube. That's part and parcel of this. What we're trying to do is to get you thinking about things in slightly different ways. So I did say that it was over to you. So younger children, there's a diagram with gaps on it on the Hale formation worksheet. Those gaps can be gained from looking at the diagram that's on the worksheet. Parents, carers, there is a version with that in. You can read those to the children that are in your care, and that should help. But for our older students, I'm going to try, if I can, yeah, it worked, to come out and go into this paint program. And hopefully you can see this okay. It looks pretty big here, so I'm just going to make it a little bit larger on the screen. So let's take this layer off and let's start. So what you want to do here, if you're an older child, is you want to draw a great big cloud. Now, actually, if you wanted a bit of fun, you could do this in a graphic design program, or you could just do it on pen and paper, which is probably the way that I would do it as well. It's useful here to have some coloured pencils here to actually to show certain things in here, or you could use coloured felt pens or coloured gel pens. It doesn't really matter. So what we've got is this great big cumulonimbus cloud, exactly as we had before. And we've got lightning there, and actually at the base of the cloud here, we can see some rain. So these are the things that I've done, first of all, to actually show what's going on. But we need to start thinking about other things. So the first thing that we talked about just now was this updraft of warm, moist air. And what this tends to do is pull the rain back up into the cloud in the simplest way. Above that, we've got circulating air, sort of in this sort of midway point here. And this circulating air will constantly sort of pull the moisture back up into the cloud, freeze it, it will start to drop, start to melt ever so slightly on the outside, and then it gets pulled back in over and over and over again. And this is slowly how we build up the little layers on our hail. So this is what you want to do to draw next. A tip here, pause the video at different points. So press that space bar and actually then go back to your diagram. Have a look on the screen, compare your diagram with the diagram that's here. That should give you a good idea of what we're doing and give you time to do it. So each time, just pause. So I'm going to leave a little space to pause. Excellent. So hopefully now you've drawn the cloud, you've got the lightning, you've got the rain coming out of it. You can show the little blue droplets. It's a little bit hard to see here on my diagram, but they are there. Blue droplets of water being pulled back onto the cloud. Our red arrow here says updraft, and the writing here says rain pulled by updraft. Here we've got little circulating sort of almost convective currents, and that says circulating air. Again, I'll pause that just so you kind of, you can pause it and draw it on your diagram. Excellent. So now let's actually add the next layer into our diagram. So what I've done here is I've actually started to show that the rain freezes, and I've drawn these little dots of hail here in my cloud. It's not quite at that really high level yet, but it's being pushed upwards and it's showing that it's freezing as it goes. So what I'm going to do, let you do that. Okay, so hopefully you've managed to draw that next layer. So what I've also continued to do is just above or just between my rain freezes, I've got little red arrows showing that these droplets are being pushed up towards this circulating air layer. You'll notice a couple of things on my diagram. When I tend to show heat in any way, and we tend to do this when we're drawing these diagrams, we tend to show heat by using kind of red arrows and red colours, and cooler air by blue. Now, I know this circulating air here is blue, but you could do it in black maybe, because I don't know, it's a mixture of air. When we're going to show a downdraft in a minute, that will be coloured blue. So just to let you know, we try and keep it simple. Again, pause the video if you need to. Okay. Next layer. Love this layer. It actually starts to look like hail now. And what we've got is lots of these big dots of heavy hail, too heavy for the cloud. And so they start to fall out of the cloud and you start to get a hailstorm. Added on here, I've got the air rising and then it starts to sink here where it says hail too heavy. We've got heavy hail written here. And of course, there are the dots that I've drawn all over it to show the hail itself. I will pause it here for you to finish that because it's going to take you a bit of time to get all those dots on. I don't know what sort of pens you've got. Okay, so almost there with this diagram. So all I've done here is drawn these blue arrows here to show downdraft. I'm sorry, my writing is a little bit difficult to read. It's because it's been done digitally. I was on a tablet, whereas it's a little bit easier on a screen or on a whiteboard normally. So apologies if it's not very good, but you get the idea, I think. And then finally, okay, I've just written the word lightning and hailstorm there. That should give us a nice, neat diagram to show us the processes that are here. Now, for older students, what I'd want you to do is to use the knowledge that you've just gained to write a paragraph to suggest or to show what's happening in this particular model here and how hail forms. If you can do that, that shows some really good understanding. Try and use the vocabulary that you may have learned today as much as possible, and try and talk about the scientific processes that you've been able to see today. Right, so hopefully I can play this from the current slide. Yes, but will it work? Okay, so now we're going to move on to Graupel. And what in the world is Graupel? Well, I've got a little diagram here that kind of gives us a hint about what it is. So people often ask, what is it and how is it different from sleet? So sleet is liquid precipitation, so liquid sort of water that freezes before it reaches the ground, and you get sleet. You often see it nearest to snowstorms or around snowstorms, and it turns, you get very, very slushy on the ground, and it's almost see-through when you see it on the ground as well, which is quite interesting. Graupel is very different though. Graupel are those snowflakes that we learnt about earlier on, but what happens is it passes through a layer in cloud where it has super cool water droplets form around its surface and actually encapsulate it in like a little ball. And these water droplets that encapsulate it like this fall to the ground, and they look like these strange little polystyrene pellets that fall to the ground. But I wanted to think about this in terms of a video. So just finding my mouse. Now, first things first, older students, again, this is a nice diagram here to actually get down and draw using your colors again and actually thinking about this. Now, what we're starting to look at here, and what's really interesting about this, is how high in the atmosphere we're going to. We're going up to, you know, like 1.9 miles high, and we've got our temperatures here showing as well. And the temperatures are in Fahrenheit, by the way. I must apologize if I ever use the term centigrade, but because I'm English and European, we tend to use those more often. But I know that we can also use Fahrenheit as well. So we've got this here, look, 32 degrees Fahrenheit, which is freezing. This is 0 degrees centigrade, and it shows how much below freezing it needs to be for this Graupel to form, and at what height as well, which is rather useful. Now, what I want to do here is I want to play this video because I think this video is rather useful. Again, this one, it's not asking you to write anything here necessarily, but it'd be important for you to, if you can explain what it is afterwards. See if you can explain what it is.
Cloud. It then falls through a layer of tiny,
I'll take that
like Dippin' Dots falling from the sky, or an explosion of styrofoam packing pellets. But this wintry precip is called Graupel. It forms in convective storms, which are the taller clouds like thunderstorms. In fact, that's what they are. You'll usually hear thunder when Graupel is falling. Several lightning bolts flashed near Georgetown on Monday, as about an inch of Graupel fell before turning to snow. Graupel starts as a snowflake which forms high in the cloud. It then falls through a layer of tiny supercooled water droplets. That means the water is below freezing but still in its liquid form. Those supercooled droplets freeze on contact with the flake, forming a thin layer of rime ice around it. The same rime ice coating gets deposited on things like conifer needles during a freezing fog event on the ground. Graupel forms in all thunderstorms, but usually melts into rain before it hits the ground. That's why you usually only see it in the beginning or the end of thunderstorm season. You will sometimes hear it called soft hail or snow pellets, but it's neither hail nor snow. It's kind of a combo. Ice-covered snow, but it's too small and soft to cause any damage. We don't keep Graupel's stats, but it's a lot more common in Colorado compared to most states. And by the way, it's spelled Graupel, so don't let your smartphones autocorrect the word when you're trying to impress your friends from Texas with a super cool Twitter post. Meteorologist Corey Reppenhagen, 9 News.
So actually that's a really nice explanation of what it is, but also you've got the diagram to the side as well. So what would be useful here is to use the video to see if you can craft your own story about what Graupel is. And it's a useful skill. This actually shows understanding that you can read something, or you can listen to something, or you can watch something and then tell the story of what it is. So parents, carers, teachers, if you're there with the students, let's ask them and see what they've learned from that video. Older students, what would be useful? Using the video, using the diagram, draw the diagram again, and actually write an explanation of what it is. If you can't remember what it is, if it's a bit difficult, go back to the video and think about what it is. And I'm going to stop that there just to let you do that. Okay, so we've looked then today at the formation of snow, the formation of hail, and now the formation of Graupel or Graupel. I think Graupel's about right, actually. What I want us to actually look at now is obviously they present different dangers. We usually have quite a long lead time in snow. All the snow's coming, it's going to be wintry, and so it's easier to prepare for. But with severe convective storms and the sorts of storms we get in spring and summer in the southern United States, sometimes hail surprises us. But we shouldn't be letting hail surprise us in that way, because we should be looking at the weather forecast as much as anything else. But also we need to be protecting ourselves and knowing what to do. So on the left here, what we've got is a really good, interesting little infographic that shows us the damage that hail can do. And here we're actually talking about sizes. And the sizes that, the sizes that we're talking about here are in inches. So a quarter, a $half, a walnut, a golf ball, or a tennis ball. These are the sizes of hail that you can get. On the right-hand side here, what we've got is the damage that hail can do. And you can see great big dings in that car there, and the windscreen completely shattered. But unlike things like houses or cars, you're a lot harder to repair, and we don't want you to getting hurt. So actually learning about the hail dangers is a really useful thing to do. I want to do this in a fun way. So I've made a creepy mystery about something that occurred a few years ago that helps unlock the damage that hail might do. So I'm going to allow you to do this. I'm going to sort of stop or pause this here, pause the video here, and see if you can do the exercise. I'm not going to give any spoilers even on the next slide and when I finish. So I need you to go in there. So again, this should be fairly easy. You might want to cut out the statements and arrange them in the right order for younger children. And that's actually a good thing to do, because we're actually taking a break from what we're doing and concentrating on something else. Older students, you might want to cut this out and arrange it in that way, or you might want to just try and work out if you can arrange the right sequence. On the worksheet, one of the things that it does, it asks you 3 pertinent things about hail and about hail dangers that you might need to know. This is a really good critical thinking exercise that I want everybody to do here. And it's really important for older students as you move towards, going through high school and going towards university later on as well. We need critical thinking skills. So it's a really, really good thing. So do pause the video here, and I'll see you for the final slide in a minute. Thank you. Hi, well, welcome back. Hopefully you've actually now learnt about snow, about hail, and about Graupel. You've learnt about how they form, the differences in how they form, a little bit of scientific facts about colours and things like that as well, but also the hazards as well, the hazards of hail. And it's something that I think is important. But there's just one more thing that I was thinking about before we finish today, and that's about lightning safety as well, because actually with hail and maybe Graupel as well, and even occasionally snow, you can actually have thunder and lightning. And the thunder we know is the noise, but it's the lightning that obviously is dangerous. So there are different ways of learning about what to do with lightning. One of the things that's been really, really useful in reducing the amount of lightning deaths and injuries over the past 10, 15 years in the USA has been learning what to do and what not to do. Well, one of the most important things that we can do is learn the 30-30 rule. Now, 30 is to do with the amount of time between the flash and the bang. When you see the flash and then count 1, 1,000, 2, 1,000, 3, 1,000, etc., if you can get to 30, then actually you're probably within a reasonably safe distance away. However, anything less than 30, they say go indoors. If you can't get indoors, obviously get inside a car, that sort of thing. And then the other 30 is that you should wait 30 minutes before going outside and resuming play, or going outside and resuming sporting activities. And actually this has been around for a while and has been really, really useful. You can find more information on lightning safety on a website that I run called eduforhazards.org, www.edu, the number 4, hazards.org. If you click on the lightning part of the suitcase there, it will tell you about lightning safety. One really good thing to learn is that if you're out and about and you can't get to a car and you can't get to a safety, we all know that we shouldn't be getting underneath trees. You need to, if you're in an open space, one thing that you can do is something called the lightning crouch. And the lightning crouch is when you, I'm going to see if this works here, but the lightning crouch is when you get down, crouch down, put your heels together so that they sort of connect together like this, crouching down on the balls of your feet and kind of putting your head up over your ears, because it might actually be very, very noisy. Hopefully you won't have to do this for a long time, but I'll tell you something, try this at home. You'll realize it's not easy to actually stay in that position for very long. So it's a good thing to practice as well. Well, hopefully that has given you a lot of insight today into snow, hail and Graupel at a time when it's probably really sunny outside. But maybe it's not. Maybe it's raining where you are. Maybe there's thunder and lightning there. And maybe we can learn a little bit more about that as well. Thank you very much for watching. I do hope that both the video and the resources have been very, very useful to you. I did forget to say at the beginning, my name's Justin Sharp. I'm a research scientist at SIMS NSSL, and what I normally do is look at the risk and vulnerabilities of tornadoes, and where I'm trying to work with a lot of other people to limit and reduce the number of deaths and injuries from these tornadoes. So that's what I do normally, but I also used to be a teacher, so I thought it'd be fun to share this with you today. Well, hope that's all for me. Have a great day wherever you are, and goodbye for now. Thanks very much.